Let's try evaluating an indefinite integral together using substitution. So here we have the integral of this x cubed multiplied by the square root of 9 minus x squared dx. These integrals with these square roots can be a little bit tricky, so I like using U-Substitution. Now before we go ahead and do that, let's just go ahead and take this square root function and rewrite it using a rational exponent or a fractional exponent, because I think that's going to be a little bit easier for us to deal with. So I'm going to go ahead and rewrite this as the integral of x cubed multiplied by the quantity of this 9 minus x squared. And instead of taking the square root of it, let's just raise it to the 1/2 power. Keep in mind that that means the same thing as the square root of that expression. All right, so now for some U-substitution. Let's go ahead and look at this expression of 9 minus x squared. Let's say that that's going to be u. So I'm going to say u is equal to this 9 minus x squared expression. Now if that's the case, if we take the derivative of u, or du, then that would just be equal to negative 2x dx. So while this 9 minus x squared is going to be replaced by u quite nicely over here, let's think about what this du is. This du is going to be this negative 2x dx. Now, for the dx part of it, this dx is going to line up nicely with this part here, but this negative 2 doesn't really have a place yet, and then we have this x here. Now, instead of this x, we have x to the 3rd power, so let's go ahead and see if we can rewrite this and be a little creative with how we write this integral. Alright, so what I'm going to go ahead and do first here is I'm going to go ahead and write this quantity of 9 minus x to the 2nd power and raise that to the 1/2 power. I'm going to write that first because we already know how we're going to substitute that. But for this x to the 3rd power, I'm actually going to go ahead and write that afterwards instead. And I'm going to write this as x to the 2nd power multiplied by x to the 1st power, or just x. And then we'll write that dx here. So basically I just moved this x cubed to the end here and I separated it into x squared times x to the 1st power, which is just x to the 3rd power. Alright, so again, we like this 9 minus x squared. We can say that's just going to be u. And then now we have this x dx, which is really close to being this, what we have over here for du. We just have to take care of this negative 2 now. And we'll deal with this x squared that is over here in just a moment. So to introduce this negative 2 into our integral, let's just go ahead and multiply our integral by negative 2, but we have to balance that out by multiplying it by negative 1/2 so that we're not really changing the value of this integral. So let's just go ahead and take this, and let's go ahead and make some room for a negative 2. So I'm going to take this part of our integral and just move it over to the right to get some room. And let's go ahead and multiply our integral by negative 1/2, but then also multiply it by negative 2. Now, it might seem a little bit strange to do that, but just keep in mind that this is really just equal to 1 because they're reciprocals. So we're not changing the value of our integral at all, and we really want this negative 2 in this integral because this negative 2x dx is going to be representing our du. At this part, this is going to be turning into u, and this negative 2x dx is going to be turning into du using our U-substitution. This negative 1/2 is not an issue because we can bring that in front of our integral as a constant. We just have this x squared that we have to deal with. Alright, so where else do we see this x squared? That's right, we can also see it over here. So if we know that u is equal to this 9 minus x squared, we can actually go ahead and rearrange this and add this x squared to both sides and take away u from both sides, and we can write this equation similarly and say x squared is going to be equal to 9 minus u. So now that we can see that x squared can also be written in terms of u, we can actually go ahead and swap everything out in our integral in terms of u. Alright, let's go ahead and do that. So making all of our u substitutions, let's go ahead and turn this 9 minus x squared. We'll turn that into u. So I'm going to go ahead and say this is going to be u raised to the 1/2 power. And then a moment ago, we said that x squared was the same thing as 9 minus u. So I'm going to go ahead and write that as 9 minus u as well. Then we have this negative 1/2, which is just going to be a constant. We'll bring that in front of the integral in just a moment. And our negative 2x dx is the same thing as du, so we can just replace that with a du here. Alright, it's starting to look a little bit less crazy. Let's just take this negative 1/2 now and move it in front of our integral. And so when we do that, we're just going to have this negative 1/2 out in front, multiplied by the rest of our integral. Then we're going to go ahead and distribute our u to the 1/2 power to each of these terms here, just to make this easier to integrate. So we're going to have this negative 1/2 out in front. And if we multiply this u to the 1/2 power times 9, that's just going to be 9 times u to the 1/2 power Nothing crazy there. But then when we go ahead and multiply this u to the 1/2 power multiplied by u, which is u to the first power, right? Keep in mind that we're going to add their exponents. So if we have 1 plus 1/2, that's going to be 1.5 or 3/2. So let's go ahead and write this is going to be minus, and this is going to be u to the 3/2 power, which is the same thing as 1.5. And of course, after we have all this, we still have this du afterwards. All right, so we're going to go ahead and put our negative 1/2 out in front still. And then what do we have if we go ahead and distribute here? So if we multiply u to the 1/2 power times 9, that's not too bad. That's just going to be this 9u to the 1/2 power. All right, don't think too hard about that one. That one's not too bad. Then we have a minus here. This one's a little bit trickier, but if we multiply this u to the 1/2 power times u, keep in mind this is u to the first power. So if you go ahead and multiply these with the same base, you can add their exponent. So 1 plus 1/2 is 1.5, which is the same thing as 3/2. So I'm going to go ahead and write that as u to the 3/2 power, which is 1.5. And it's going to be this whole thing multiplied by du. All right, now it's time to integrate. All right, so let's go ahead and take the integral of each of these parts. So for this first one, we have this 9u to the 1/2 power. So I'm just going to do each of these individually, and then I'll put them back together in just a moment. So when we take the antiderivative of this, let's go ahead and add 1 to the exponent. But then we have to go ahead and divide that by that same exponent. So 1 plus half is 1.5 is 3/2. So let's go ahead and divide this by 3/2. Now if we go ahead and divide by 3/2, that's the same thing as multiplying by 2/3. So we really have 2/3 multiplied by 9. And we also have this u raised to the what power? Well, this 1/2 plus this 1 is going to be that 3/2 that we kind of have seen a few times now. All right, now 2/3 of 9 is just equal to 6. So we can say this is equal to 6u to the 3/2 power. That's going to be the antiderivative or the integral of that part of our integral. All right, moving on to this part of our integral, we have this u to the 3/2 power. So if we go ahead and take this u to the 3/2 power, and if we go ahead and take the integral of that, let's go ahead and add 1 to the exponent, and that's going to be 3/2 plus 1. 1 is the same thing as 2/2. So 3/2 plus 2/2 is going to be 5/2. Let's go ahead and divide by that exponent of 5/2. Now again, dividing by a fraction is the same thing as multiplying by its reciprocal, so we can rewrite this as 2/5 multiplied by this u to the 5/2 power. And so if we go ahead and take that antiderivative, we can just say this is going to be 2/5 u to the 5/2 power. All right, so now that we've taken the antiderivative, let's not forget about that c, but we have this negative 1/2 out in front, right? Let's go ahead and multiply that by this 6u to the 3/2 power that we found out from that first part. So that's 3/2 power. And then we have minus what? We have minus this 2/5, and that's going to be multiplied by u to the 5/2 power, just like that. And then we are going to just have a plus c afterwards here. Now if we go ahead and just distribute this negative 1/2 to both of these terms inside here, so negative half times 6 is going to be negative 3. So we're going to have negative 3 times u to that 3/2 power. And then we take this negative half and multiply it by the negative 2/5. That's going to be positive 1/5 multiplied by u to the 5/2 power. And then we have plus c. All right, at this point, we're done integrating. We can go ahead and just make our substitutions back here. So let's try to remember what did u actually represent. We said from the beginning that u was going to be representing this 9 minus x squared. So let's go ahead and make that substitution back now. We're going to write negative 3 multiplied by that 9 minus x squared. Go ahead and raise that to the 3/2 power. And then plus the 1/5. Multiplied by that same thing of 9 minus x squared. And that's going to be raised to the 5/2 power. And at the end, we have this plus c. This right here would be the value of that integral. Now, it's possible that you see your solution in a slightly different form, so let me show you another way you could also write this. And so another way you could write this is just dealing with some exponent rules here. So instead of writing this negative 3u to the 3/2 power, we can say this is going to be negative 3u to the 2/2 power, which is really just 1, multiplied by another u here, and that's going to be raised to the 1/2 power, right? So we're just kind of separating this, but you can hopefully see here that this u to the 3/2 power is the same thing as u to the 2/2 power times u to the 1/2 power, because you would just add their exponents to get what we just had a moment ago. And we can do something similar here with this u to the 5/2 power. So I'm going to go ahead and write this as plus 1/5. And then multiplying this by u. Let's see, it's going to be u to the, I'm going to rewrite this as u to the 4/2 power. And you'll see why in just a moment. And I'm going to go ahead and multiply this by u to the 1/2 power. All right, so just some like rules of exponents that you may have learned in the past, hopefully, or just maybe a little bit fuzzy, just kind of writing this out clearly. So this u to the 4/2 power times u to the 1/2 power. Remember, you can add those to get the u to the 5/2 power since they have the same base. Now this 2 over 2 power is really just 1, so you can rewrite this as negative 3u to the first power, or just u. And then we can also rewrite this as to the 1/2 power. Instead of saying u to the 1/2 power, we can say this is going to be multiplied by the square root of whatever u is here, right? So that's one way to write this. And then we can also write plus this 1/5 here. And then what's this 4 over 2 power? That's just going to be 2. So we're going to say that this is going to be multiplied by u to the second power. And then again, we have this u to the 1/2 power as we had earlier. That's the same thing as the square root of u. So I'm going to go ahead and write square root of u. And then we have this plus c. And so at this point, if we go ahead and replace all our u's with that 9 minus x squared, it would look something like this. And so you might see your solution looking something like this, but you can also go ahead and expand these binomials here. And so if you FOIL that out, that's going to be 81 minus 18x squared, and then plus x to the 4th power. This would just be another form of the same solution. Alright, so this was a little bit trickier of an example of using U-substitution. In this particular case, we just had to manipulate some things a little bit more, and we also had to have a pretty good understanding of how rational exponents or radicals work as well. If you found the video helpful, please consider sharing with a classmate or friend who might also find it helpful, and as always, keep up the great work that you're already doing.